The lesson for today involved with the previous lesson about the slope-intercept form is the different forms of linear equations, in which slope-intercept form is one of those three forms. So what we're going to look at is we're going to look at standard form, point-slope form, and slope-intercept form and identify them. We're going to review the slope-intercept form and convert to slope-intercept form. We're also going to graph linear equations using slope-intercept, which we've done before, but I'm doing it again so we reinforce that. And we're also going to determine whether graphs of linear equations are parallel, perpendicular, or neither. And this is something that is important because it is something that is tested on the test. And then finally, recognize and use standard form of an equation of a line. So this is standard form. Standard form is a number with an x and a number with a y, or just an x and a y, and then a 12. All of these forms have an x and a y. Now in this one, you have a 6 times x plus a 2 times a y, and that'll give you 12. That's just standard form. That's all it is. You haven't solved for anything but the whole number in this situation. That's why it's standard. It's like solving any other equation because on one side of the equal sign you have a couple of variables, x and y, and on the other side you just have a number. So it's standard. Now the slope-intercept form, which we looked at previously when looking at slope, is this y equals mx plus b. And as a review, y is y, x is x. That's present in every one of these, x and y. M is your slope, which in this equation would be 2. And then b is your y-intercept, which is where the line crosses the y-axis, which is the axis that goes up and down. And that would be at -4. So if I were to graph this line, it would cross at -4. So, if I have a graph, it would cross down here at -4, and the slope would be 2 over 1. The rise would be 2 for every run of 1. So it would do like that. Point-slope form is a little bit different. You can solve from one to the other one, but in point-slope form, you have a point that is present. And that would be that y1 and that x1. This means these are the x and y coordinates of one of the points. So in this one, it has the slope, which is 2. There's your slope. And then it also has a point. That would be that -3 and that -6. Those are points on this line. And then the x and the y are present as usual. So, point-intercept, the slope-intercept, here's your slope, 2. Here's your y-intercept, -1. In this one, though, if we have 2y equals 8x plus 4, to solve for slope-intercept, first you have to solve for y. That's the important thing you have to solve for. So to solve for y in this equation, what do? We'll divide by 2. So divide both sides by 2. So 2y divided by 2. Where's my, there it is. 2y divided by 2 would just give me y, which is what you want on that side. 8x divided by 2 would give you 4x. And 4 divided by 2 would give you 2. So that the slope-intercept form of this equation would be y equals 4x plus 2. Any standard equation can be solved to solve for y this same way. Again, slope-intercept form. We want to get y by itself to get to slope-intercept form. So to do that, we got to first get rid of what is not with y that's on this side of the equal sign. So here we have -8 that we're going to get rid of. So we're going to add -8x, that we're going to get rid of. So to get rid of that -8x, we add 8x to both sides. When you add 8x to both sides, that gets rid of the 8x on this side, and it adds the 8x to that side. So now you have 8x plus 16. You could also write it as 16 plus 8x. But typically, whenever you write these things, you write the number with x first and then just a whole number by itself second. Notice you do not add 8 to 16. You don't end up with 24 or 24x. They have different last names, different terms, so you do not add them together. So now I have 4y, or 4 times y equals 8 times x plus 16. You need to divide both sides by 4 to get rid of that 4, because you want y equals number. So to divide both sides by 4, I divide 4y by 4, I get y. I divide 8x by 4, I get 2x. I divide 16 by 4, I get 4. And so my answer is y equals 2x plus 4. You need to we're also going to look at using point-slope form to write the equation of a line. So here is the point-slope form. Point-slope form, you have y, which will be y, x, which will be x, and then the point, whatever point they give you, the y-coordinate, or the second part of that point, will go here. The x-coordinate will go there. It's just plugging into a formula. And then the m is the slope. So write an equation of the line with the slope negative 5 over 3, that's the fraction 5 over 3, passing through the point 3, negative 1. So to do that, we use our regular formula that's here. Now remember, the slope was negative 5 over 3. So we say negative 5 over 3 for m. So that's where m goes, negative 5 over 3. So that negative 5 over 3 is where m is. So we plug that there. And then the point itself was 3, negative 1. So 3 is the x1, negative 1 is the y1. So the x1 is 3, and the y1 is negative 1. Well, now that we have that, we can simplify this equation a little bit, make it a little bit better. So first what we do is we'll say y minus a negative 1. If I get rid of something that's already negative, that makes it positive. That makes it y plus 1. This negative 5 over 3 was the slope. It stays the slope. But here, we'll say negative 5 over 3 times x, which is negative 5 over 3x, or negative 5 over 3 times x, and negative 5 over 3 times negative 3. Well, negative 5 over 3 times negative 3, or negative 3 over 1, is going to be positive 5. Negative times negative gives you a positive. So now what I have is y plus 1 equals negative 5 thirds x plus 5. And I really don't like this problem because it has the fraction like that, but it's the most simplistic problem I could find to substitute in. Now I've got to get rid of this 1. So instead of saying y plus 1, I subtract 1 from both sides. So I subtract the 1 from this side, gets rid of that 1. I subtract the 1 from the positive 5, not from this because it doesn't have the same terms. That 1 doesn't end in an x, so I don't even deal with this 5 thirds. So I'll say minus 1, gets rid of the 1 over here. 5 minus 1 is 4. So now I've converted from slope-intercept form, or from point-slope form to slope-intercept form. So the equation of the line is negative 5 over 3, or negative 5 thirds x plus y, plus 4. So the slope-intercept form, we use that to write an equation of a line. So the equation of the line with the slope m, and then wherever it crosses the y-intercept, which means x will be 0 and b will be the y-intercept. They use b because using y again is a little confusing. So use the slope-intercept form to write the equation of a line with a slope of 4. So 4 is going to be where m is. 4 is going to be right there. Y is going to be y, x will be x, but we got to find the y-intercept. And it passes through the point 5, 9. So here's how you do that. Here's how you find the y-intercept. So you're going to plug in 9 and 5 because those are the points. Because we know that m is the slope and the ordered pair is 5 and 9. Well, guess what? When I plug in 5 for x, because that's an x, y coordinate, 5 and 9. So I plug in the 5 for x and the 9 for y. Then what I've done now is I plugged in the 9 for y, the 4 for m, the 5 for x. Guess what? I'm only looking for one thing. If I'm looking for one thing in an equation, I can find that one thing and solve. So 9 is 4 times 5 plus b. So now all I do is say 9 equals 4 times 5 is 20 plus b. 20 plus something will give me 9. So when I subtract 20 from both sides, 20 minus 20 gives me 0 plus b, which is b. And 9 minus 20 will be negative 11. So because the slope m is 4 and the b is, or the y-intercept is negative 11, the equation is y equals 4x minus 11. Now we're going to graph linear equations using the slope and intercept. Find the slope and the y-intercept of the line with the equation 3 times y plus 2 equals 6x minus 1. So what we're going to do first is we're going to distribute this 3 times y and 3 times 2. So 3 times y is 3y, 3 times 2 is 6, and then 6x minus 1. So now I've got 3y plus 6 equals 6 minus 1. Now I'm going to subtract this 6 from both sides. So I subtract the 6 from here, gets rid of the 6 on this side. I subtract the 6 from here. Negative 1 minus 6 is now negative 7. So 3y equals 6x minus 7. Now all I do is divide both sides by 3 because I want y. Y equals something. So to do that, I'm going to say divided by 3. So 3y divided by 3 gives me just y. 6x divided by 3 will give you 2x. Negative 7 divided by 3 is negative 7 over 3. The slope of a graph is 2 and the y-intercept is now 0, negative 7 over 3. That's the y-intercept. If we find a second point on the line by moving 1 unit to the right and 2 units up, because that would be our slope is rise over run, 2 over 1, because the slope, remember, is 2. So the slope is 2 or 2 over 1. So we go rise, up 2, and over to the right 1. If we go up 2 and over to the right 1, then it says our point is 1 negative 1/3. So what they've done is they've subtracted the 2, or added the 2 to the y, because that's the up and down one. So that's up 2. You went from negative 7 over 3 to negative 1/3. Negative 7/3 plus a positive 2 will become negative 1/3. And I moved over 1. So that would be 1 for my x coordinate. And the graph looks like this. If you're really wondering what it looks like this. So they graphed it. They went over 1 and up 2. So this is a weird one, and I really don't like this one, but it was the best example I could find. So they went over 1. So they went from 0, negative 7, 3, negative 7/3. So they went over 1 and up 2. So over 1 from 0 to 1 and up 2. From negative 7/3 to negative 1/3. Now we're going to determine whether the graphs of linear equations are parallel, perpendicular, or neither. Now, this is important. Parallel lines have the same slope. That means they're going the same direction at all times. Perpendicular have the direct inverse slope. That's the key thing. It doesn't matter about the y-intercept. As long as you can get to that slope-intercept form or get to some form where you have just slope, you just compare slopes. That's all you really do here. So parallel lines, two different non-vertical lines are parallel if they have the same slope. So this line right here they give you has a slope of 1/2 x. Doesn't matter if it's plus 5, minus 8, plus 13, minus root of omega, whatever. They don't matter. The most important thing is that. So that has a slope of 1/2 x. This has a slope of 1/2 x. Guess what? They're parallel. Same thing here. If x is 2, negative 2, and x is positive 4, those are parallel because they're vertical. They're up and down. They don't have a y whatsoever. They just keep on going on the x. Now, numbers are perpendicular if they are if they meet at 90-degree angles. So to compare the slopes of that, first you have to get to that slope-intercept form. Then you look at the slopes. They are the complete inverse, meaning sine is the complete opposite. This one was a negative 2/3 x plus 3. This one was a positive 3 over 2x. So the sign went from negative to positive, and they flipped the sign the other direction, or flipped the equation. Flip the, hang on, let me get this right, slope. Get it right in my brain here. It was 2/3, now it's 3 over 2. So if up here on this one, they're parallel, if the slope of this one's 1x, the slope of that one's 1x, they have the same slope. Then they are parallel. If the slope of this one, though, let's say was just 1/2, negative 1/2, and the slope of this one was positive 2, they would be perpendicular, because positive 2 is positive 2 over 1, which is the complete inverse sign and situation of negative 1/2. So determine whether the lines of 4x plus 8y equals 10 and 2x equals 12 minus 4y are parallel, perpendicular, or neither. So to solve this, we got to solve for y. So we need to find the slope of each line and compare them. If the slopes are same, then they're parallel. If the product of the slopes, and they're saying if you multiply them together and you get negative 1, then the lines are perpendicular. I say if you can flip the slope over and compare the signs, then you know. So let's look at these two. This first one is 4x plus 8y equals 10. We got to get y by itself. So the first thing we're going to do is we're going to subtract 4x from both sides. Then we're going to divide both sides by 8. So on this one, it becomes negative 1/2 x plus, and it was 10 over 8, which is reduced to 5 over 4. And on this one, what they did was they went ahead and switched up everything around. Well, what they did was they flip-flopped this negative 4y and this positive 2x. What they did is they added the 4y to this side and then subtracted the 2x to that side. So you have y all by itself, which is fine. So 4y is equal to negative 2x plus 12. That's when you flip everything around, added the 4y, subtracted the 2x, and we're to here. Now we got to divide both sides by 4 because we want to get rid of the 4, so we just have y. So negative 2x divided by 4, 12 divided by 4. Negative 2x divided by 4 is negative 1/2, and 12 divided by 4 is 3, which really doesn't matter. But yes, look, this one has a slope of negative 1/2. That one has a slope of negative 1/2. So guess what? They are parallel to each other. Since the values of b are different, though, the lines are different. This one crosses at 5 over 4, positive 5 over 4, like 1 1/4. This one crosses at 3, crosses the y-intercept. But since their slope is negative 1/2, the lines are parallel. Now we're going to do one last thing, which is write the equations of parallel and perpendicular. Oh, we're not going to do that. Sorry. We're going to recognize and use the standard form of the equation of a line. So, standard form is that something x plus something y equals a number. And b cannot be 0. That's the important thing here. So, find the slope and the y-intercept of the graph. 4x minus 2y equals 6. So to do this, we got to first move that 4x to this side. So we're going to subtract 4x, solving for y. 3x, I meant to be 4x. Sorry, I kind of borrowed this and didn't change everything like I should have. So that should be 4x on that side. Subtract 4x from both sides, like this, see? Minus the 4x, minus the 4x. So now we have, all we have left on this side is this negative 2y equals 6 minus 4x. Or you can flip-flop these two, so it could be negative 4x plus 6. So it's negative 2y equals 6 minus 4x, or negative 2y equals negative 4x plus 6. Now you just get rid of the 2. So divide both sides by negative 2 to get rid of that negative 2. So I'm going to say 6 divided by negative 2 and negative 4 divided by negative 2. And so what you end up with is y is 2x plus negative 3. The slope is 2 because that's what's with x. And the y-intercept is negative 3, or 0, negative 3 is the actual thing. So, forms of a line. Standard form, you have something x plus something y equals a number. Slope-intercept form is y equals mx plus b. Y and x are standard, they're just there. B is the y-intercept. Wherever it crosses the y-axis, m is the slope. And on this one, y stays y, x stays x. Y1 is the point for the first one, or the y point for the line. This is the x point for the line. M is the slope.